about the significant figures, and there I told you about significant figures, what is the rule for addition and subtraction. So when you go for addition and subtraction, of significant figures, results are reported on the basis of lowest decimal place. Say I have taken here 4.234. It has how many four significant figures? It has 4 significant. Okay, let me write as SF. Then say it is 23.4. So it is 3 significant figures. So now let us assume it is 0.346. So it is also having 3 significant figures. Why? Because if you have a 0 before the number, that is not being considered. Okay. So now you add it. How much it comes? 4 plus 6 is 0. 3 plus 4, 7 and 8. Then 2 plus 4, 6 plus 3, 9. And it is 7 and so this is the result. Now see, it has 3 places after decimal. This is also having 3 places after decimal, and this is having 1 place after decimal. So you are supposed to write this result as correct result. Then you are supposed to write at 27.9. Okay. Now for multiplication and division. For multiplication and division, result is expressed with minimum significant figure. Okay, say it is 142 so it is 206 and it is to multiply by 0.23. Okay, so the result comes as 32.678. 6738. Okay. So now see, it is having 5 significant figures, and this is having 2 significant figures. So the result is yes. So no, it will come as 3.2. 3.2. So it will be reported as 3.2 because the minimum significant figures is 2. So this one you please remember. So write down. All right. So I think you finished.
Sir.
Hello.
Yes, sir. Sir, this topic comes under some basic concepts of chemistry.
Yes, yes.
Yes, sir.
I have already sent you the summary.
Yes, sir.
See now. Now, as we when we come to the chemistry, I told you, here we deal with matter. So what is matter? Any substance which has existence and mass is called matter. Any substance which has existence and has mass is called matter. Okay. So in our philosophy, we talk about the existence of life. In Sanskrit, we call it Atma. Okay, but it is not a matter because you never felt it. Even if you feel, suppose philosophically you feel the existence, but can you take the mass of it? So it is not a matter. Okay. So now, how many types of matters are there?
Three.
5.
5 types are. 3 we are very frequent with it. Solid, liquid.
Gas.
Then what is the 4th one?
Plasma.
Yes. Plasma state. And what is the 5th one?
Bose-Einstein condensate.
Yes, it's called Bose-Einstein condensed state. It is difficult to find plasma state in the earth. Plasma state is the one where you take out all the electrons from an atom. But these electrons, they do not fly away. They remain nearer to the atom. So that is the plasma state. Okay. So plasma state generally exists where there is a very high temperature is there. Say it is more than 1 million times. So plasma state is available in stars. Oh. Now, how to distinguish this solid, liquid, and gas? Solid has fixed shape. If you don't destroy it, its shape is not going to change. Then it has fixed mass and it has fixed volume. When you go for liquid, it does not have any fixed shape. It has fixed mass and volume, because it will take the shape of the container in which you pour it. Gas only has fixed mass. So please remember. Now, matter can be also classified in other way. Matter also can be classified in other way as pure and impure. There are 5 laws are there. 4 laws deals with the mass and 1 deals with the volume. So there are 5 laws of chemical combination. 4 of them deals with mass and 1 deals with volume. Okay. So what are those which deals with mass? First, you know, this is called law of conservation of mass. Second one, law of constant or definite proportion. Third, law of reciprocal proportion. Sorry. Law of multiple proportion. Fourth one is called law of reciprocal proportion. So all these 4 deals with mass. Fifth one also you have studied in school. This one you did not study. This is called Gay-Lussac's law of gaseous volume. That depends upon volume. Or the name itself you understand. Okay. So now let me write down the definitions. This is nothing but revision. Law of conservation of mass. In all chemical changes, the total mass of the system remains constant, or in a chemical change, mass is neither created or destroyed. See, as because we follow the law of conservation of mass, always we have to balance chemical equations. That is, left hand side should be equal to right hand side. So chemical equations are balanced following the law of conservation of mass. Okay, this is our first law. Sorry. So this is one. So now let me change. Now let us go for second. Law of constant or definite proportion. A chemical compound always contain same number of elements combined together in fixed proportions by mass. Okay, for example, say I want to prepare water by combination of hydrogen and oxygen. See here. Here, the weight of hydrogen is 1 if you consider. So the hydrogen element, if it is 1, in fact, it is not 1, 1.008. Anyway, forget. Let us consider 1. So H2 means 2. So what will happen now here? 2 into 2 gram of hydrogen combines with atomic mass of hydrogen. Oxygen is 16. So it is 32. So what do you find here? That is 4 gram of hydrogen combined with 32 gram of oxygen to give 36 gram of water. Okay? Or I can write 2 gram divided by 2. 16 gram, it will give you what? 18 gram of water. This is the ratio of 2:16. If you want to bring it further, that is 1 gram of hydrogen will combine with 8 gram of water to give you 9 gram of water. Now, if you make water by any method, it's not that always you can get water by burning hydrogen in an atmosphere of oxygen. You can make water by different processes. Any part of the universe, if you get water, always the ratio will be 2:16 or 1:8 by mass. So that is called law of definite or constant proportion. Let me finish, then I will do 1 or 2 numericals. Then you will understand. Okay? So you can write moment you finish writing, you tell me.
Finished, sir.
Okay. So now I write the third one. This one I think you did not do, or maybe you have done, this not you wrote. Law of multiple proportion. Okay, see here. If two elements combine to form more than one compound, then the different masses of one element which combine with a fixed mass of the other element bear a simple whole number ratio. This definition may be a little bit complicated, but it is very easy. Maybe don't go by these English words. So let me see here. Hydrogen and oxygen combines to give us water. And hydrogen and oxygen also combines to give us hydrogen peroxide. Okay, so let me balance it. Yes. So what should I write here? See here. Let me write it here. See, I'll write here 4 gram combines with 32 gram of oxygen to give us what? 36 gram of water. All right. And here 2 gram combines with 32 gram of oxygen to give you what? 34 gram of hydrogen peroxide. Okay, now see. Is it not both of them have the same weight? 4 gram combines with 32 gram of oxygen and 2 gram combines with 32 gram of oxygen. So what does it say? The masses of one element which combine with the fixed mass of the other element. So both of them are fixed. So here you can, I have, as because it is similar, so I have taken fixed. If it is not similar, then you find out how much is combined for 1 gram. If you take 1 gram, that also will be fixed. So then the different masses of one element which combine with the fixed mass of other. What is the different masses? Here is 4 gram and here is 2 gram. We are a simple whole number ratio. Dear, see here, what is the ratio now? It is 4:2, or I can write 2:1. So is it not both of them are whole number? So this is called the law of multiple proportion. Okay. So we find the same element may combine to give us many compounds. In case of hydrogen and oxygen, only 2 compounds are there. If I take nitrogen and oxygen, I can get 5 compounds. But when they combine with the fixed weight of 1, and you find the masses, you find they bear a simple whole number ratio. So now you understood. Huh? So this is the fixed mass. And different masses are 4 and 2. So when I take the ratio, we find it is also whole number, this is also whole number. And mind it, we have taken this 4 and 2, where from you got it? By their mass. Okay? So now I will go for law of reciprocal. Law of reciprocal proportion. Okay. So I'll write down, then I'll explain. When two different elements separately combine with a third element, so with a fixed mass of third element, the ratio by which ratio by mass by which they combine with the third element bears a simple whole number ratio when they combine with each other. So don't get scared, huh? When I explain it to you, you'll find you'll understand. See, let us take carbon, hydrogen, and oxygen. See, hydrogen and carbon can combine to give you CH4. Carbon and oxygen can combine to give you carbon dioxide. Okay, so let us find out by mass. See here, CH4. This is atomic mass is 12, this is 1, and this is 16. So what I can write here, 12 gram of carbon combines with 4 gram of hydrogen. 4 are there. Okay. And in case of carbon dioxide is what? See here, 12 gram of carbon combines with oxygen is 16, so this 32 gram of oxygen. So you see here, both of them weight is same. So 4 gram of hydrogen and 32 gram of oxygen combined with fixed mass of carbon is 12 gram. So what is the now ratio here? Ratio is hydrogen versus oxygen. Ratio, it is 4:32. So if I divide it by 4, 1:8. Okay, now see. Hydrogen and oxygen also combine with each other to give us water. So let me write here H2O. So 2 gram of hydrogen combined with 16 gram of oxygen. So what is the ratio now here? See here, 2:16 is equal to what? 1:8. See, is it not same? So either it may be same or it may be multiple of that. If not 1:8, it may be 2:16, 3:24, 4:32, like this. So this is called the law of reciprocal proportion. Write down. See, moment you finish, you please tell me. I don't know.
Finished, sir.
So please tell, then I will read it up. So now these three laws, could you understand?
Yes, sir.
Okay. Now we'll go for the fifth law. This is known as law of gaseous volume, or is known as Gay-Lussac's law of gaseous volume. What does it say? Gases react with each other in simple ratios of their volume. And if the products is also gaseous, they bear a simple ratio by volume. Okay, see here. Suppose you have taken hydrogen gas and you have taken chlorine gas. This will give you hydrogen chloride gas. Here we are not measuring their mass. What is this? This is 1 volume. This is also 1 volume. This is 2 volumes. So what is the ratio now here? Hydrogen is to chlorine is 1:1. Now luckily, this is also gaseous. So in that case, what should I write now here? Hydrogen is to chlorine is to HCl is 1:1:2. Now it may not be applicable for all. All gaseous reaction need not give us gaseous product. Say I have taken here ammonia gas, HCl gas. It will give you ammonium chloride, but mind it dear, this is solid. So the rule is applicable on the left hand side. You cannot extend it to right hand side. So here it is. This, not this.
So how did you get 1:1?
Okay, now
So how did you get 1:1?
which one? See, this is one. This is one or no, one molecule or not. So volume is one. So it is one volume. This is one volume. So 1:1. And this is solid. So I cannot say it's one volume. Okay, now we'll do one small numerical. If you do not do numerical, you don't understand science. In an experiment, 2.4 gram of iron oxide on reduction with hydrogen yield 1.68 gram.
So I didn't get you.
In an experiment, can you see in an experiment 2.4 gram of iron oxide on reduction with hydrogen yield 1.68 gram of iron. In another experiment, 2.9 gram of iron oxide give 2.03 gram of iron. On reduction with hydrogen. Show that the above data illustrate the law of constant proportion.
So what is written of the constant law of constant proportions?
Law of constant proportions. Okay, now how to do it? So let me clean the board. So we have now done 2 experiments. So this is experiment 1 and this is experiment 2. Okay, now what is the mass of iron oxide? Mass of iron oxide. How much it is? 1.68 gram. Okay. Now, iron oxide is a compound of iron and oxygen. And what is the mass of iron after reduction? I'm logging in by a phone. It is, sorry, it is 2.4 gram. And 1.68. And in this case, this. So if I subtract this one, then I know mass of oxygen. So how much it comes? It is 2, then it is 7, and this is 0. And here, mass of oxygen is, let me subtract 7, 8, this. Then we'll find out. Ratio of iron is to oxygen. How much it comes? See here. It is 1.68 is to 0.72. And here, ratio of iron is to oxygen is 2.03 is to 0.87. So let us divide it by, let me divide this one by 72. So it will be 1.68 divided by 0.72 is to 1. And this is 2.03 divided by 0.87 is to 1. So find out what is the value. So it is 2.33 is to 1. Okay. And we find interestingly, this is also 2.33 is to 1. See here, they combined with the same ratio. So what we write? Thus, these results are in agreement with law of constant proportions. So done.
Yes, sir.
No,
Yes,
I
sir.
have been telling you, after moment you finish, you tell me. Because after writing, if I immediately rub it, then you will not be able to write. And if you don't send me, then I have to wait for a long time, then I will not be able to do the next thing. So leave this habit of sitting idle. Two compounds each containing tin and oxygen as the following composition. Compound A, compound B. See, this is a symbol of tin and this is a symbol of oxygen. Okay? So I'll write here. Mass percent of tin and mass percent of oxygen. So it is 78.77 and 21.23 and 88.12 and 11.88. Show how data illustrate law of multiple proportions. Okay, write down. Moment you finish writing, tell me. Then I will start the
Finished, sir.
Okay. So we go for now solution. See here, law of multiple proportion says what? When one element, mass of one element combined with the fixed mass of the other. So none of the masses are fixed. So what should I write now here? We'll write. See, it is compound A. So what did you find here? Oxygen combined with 78.77 gram of tin. So let us make it 1. Okay, so I can write. Therefore, 1 gram of oxygen combined with 78.77 divided by 21.23. 2, 3. So how much it comes? So it will be equal to 3.7 gram. Okay. Then compound B. We write now here 11.8 gram of oxygen combined with 88.12 gram of tea. So therefore 1 gram combined with 88.12 divided by 11.88. Okay. So that comes to around 7.4 gram. So let us take the ratio. So what is the ratio of oxygen here? Therefore, the ratio of oxygen is equal to what? 3.7 is to 7.4 equal to, if I divide it by 3.7 divided by 3.7 and 7.4 divided by 3.7, it comes to 1:2. See, is the whole number ratio. So last you'll write, thus it follows the law of multiple proportions.
So can you explain the last part again?
See, what does it say? It says the different masses of the substance, different masses of the element which combines with the fixed mass. Okay?
Yes, sir.
Oh, sorry. Here it will not be oxygen because one fixed mass of oxygen, na? So we'll write here T. So it is T. So it says when they form more than one compound, so the different masses of one of the element which combines with fixed mass of the other always bear a simple whole number ratio. So what we have taken here, we have taken fixed mass as oxygen. What is the fixed mass? 1 gram. So here it is 30.7 gram of tin, and in this case is 7.4 gram of tin. So what is the ratio now? Ratio of tin is 3.77 is to 7.4. So in ratio, what you do? You have to divide it by lowest number. Divided by lowest number 3.7, 3.7, it is 1:2. So in that case, we find that it satisfies the laws of multiple proportions. This is the way you have to do.
Done, sir.
Okay, then today we'll stop here.
Okay, sir.
Thank you, sir.
Thank you,
Welcome.
Thank you,
sir.
sir.